Post the lectures on the YouTubes. Let's take a major step back in time. If I had a uniform, I guess it's not a major, distribution from, let's say 7 to 15. Can you draw that for me? Kind of rebuilding our way up to where we left off. All right, so when I say to draw this, sometimes that people do this, and that's all they do, or they do give me the height. What will the height be? No. Yeah. So it's always got to be the reciprocal of how long it is, because I want the area to be 1. What's the only kind of numbers I can multiply to get 1? Reciprocals. So that's 8. This is going to be 1/8. They give me this, and that still isn't right, because I don't see any distribution there. So you got to draw me that big ass box, right? This whole idea of uniform distribution is they all get the same probability. So everybody has the same height all the way across. I like it. Somebody help me out. What kind of distribution is this? How many numbers are in here? I love you guys. I want you to count like 7.3869. Is 7.3869 in here? What about 11.222222222222223? Is that in there? Yes. Holy shit. So how many numbers are in here again? Infinite number of numbers. This is a continuous distribution. The one you just took a quiz on is a discrete distribution. I can see the only possible values. It skips values. I like it. So what's the idea? If I ask you what's the probability that I get x between 8 and 10, you could draw that in the picture, right? 8 to 10. You can shade in the area I want, and then I have to calculate that area. So what do you guys get for the area? Let's say the length is 2. The height is 1/8. 25%. Is that cool? Everybody with me? A little bit? Okay. So, look at the comparison to that with a normal distribution. If I tell you I have a normal distribution, and let's say it's a standard normal. I don't know if I've used that. Standard normal just means I've got z-scores. Who remembers what would be in the middle? Good. The mean always becomes 0 if I have z-scores, because a z-score is how far from the mean to this data point in standard deviation, so it'd be 0. It's 0 away from itself. Did I tell you, I told you last time, the question I'm going to ask on every test from now on? Have I told you that yet? So just to remind you guys, and I'm waiting, I'm hoping that I get more than half get it right. This question that I'm telling you is on the test, and I'm going to tell you the answer. I'm hoping I get more than half. Yes, I am being a dork, but I just freaking get it right. What does a z-score tell you? The number of standard deviations from the mean to the data point, right? So a z-score is just a unit of measure. Instead of using inches or feet, we use standard deviations, which is kind of like an inherent tick mark to use. Based on the data, my tick marks are the average distance from the mean, which is the standard deviation. Okay. Everybody with me? So that question will be on every test. And it always has the same answer. What if I said, what would a z-score of 3.17 mean for a data point? That data point is 3.17 standard deviations away from the mean, or even above the mean would be great, but away is fine. Don't just say 3.17 away from the mean, because I'm going to be an asshole. I'm going to write miles, light years, right? What unit of measurement do we use in statistics? Standard deviations. That's the inherent unit of measurement that we use. Okay, maybe. Okay, so that's why that's 0. That's the long-ass explanation why that's 0, because the mean is 0 away from itself. That's amazing. So what if I want to know what's the probability that a z-score is between 0.8 and 1.0? Can I graph that on the picture? Where would 0.8 be? This is the part that kind of drives me. Look, I get somebody put 0.8 there and 1.0 there. I'm like, what the hell? That's 0. 0.8 is over there somewhere. 1.0 is over there somewhere. It don't matter if it's to scale, because the picture is just supposed to help me. Should that be a big answer or a kind of small answer? Should definitely be a small answer. It's going to be less than half for sure. You guys all semi with me? All right, so here's how to do this. So everybody has this. Do you have it, Jeff? Oh, there it is. All right. Everybody has this guy, right? So we did focus last time a lot on how to read this. So there's 2 z-scores. So now I really want to make this clear. Do you see how we got to the same place right here, right? We drew it on the distribution. We shaded it in. The area of that will be the answer. Up here, it was a shape. I could do the area. I don't need somebody to give me a freaking chart. I can do the area of this, right? Down here, chart of answers, please, right? What's the formula for this shape, area? You don't know. Which is fine, because you need calculus, and you can't even do it with calculus 1, to be honest. You need like calculus 3 to be able to do it. So thank God we got this. So this takes the place of this. I can't calculate the area. I have to look it up. So if I look up 1.0 on this, so you got to go to the positive side. 1.0. If I wanted 1.02, I would have gone here. That's 1.02. So this top one tells me the second decimal place. That's the best way they can construct this, so it could be on one piece of paper, front and back. Okay, maybe. So what do you get when you look at 1.0? 8413. Where is that area? The chart always tells me the area below or to the left of what I looked up. So I can immediately put 0.81413 there. Is that too much area or not enough area for the answer? It's too much area. How much area too much? Well, if I could figure out what this area is, that's exactly how much too much it is. I can subtract those two. Does that make sense? I like it. So if I look up 0.8, 0.80, yeah, 7881, so that's going to be here. So to get the actual answer, I have to do 8413 minus 0.7881, become an 8. Do it again. I'm trying to do it in my head. Just give it to me. 0.05? No. 0.5? Yeah, 5, 3, 2 there. All right, thank you. So about 5% would be in between those. So if a test was normally distributed and your z-score for the test was 0.8 and your friend's z-score was 1.0, then 5% of the class would have had grades between your two grades. That does not immediately sound useful yet. All right. But this problem again, I'm just going to wait. Right now we are doing the nuts and bolts of how to use z-scores, how to use the chart. This is the underpinning of a lot of early statistics, is the idea of z-score. It's crazy. All right, stay with me now. How do I do, let's do one more of these. Let's probably z is greater than negative 0.97. What? So draw the picture. Negative 0.97 is down here somewhere. And then shade in the area. It's greater than, right? And that's an arrow that points me which way to shade. So now if you look up, go ahead and look up on the chart, negative 0.97. Don't say anything out loud yet. That's neato. I like that one. Sounds like a history test. What do you get when you look up negative 0.97? Yeah, 0.1660. Don't just put it down and circle it. Where does it go in the picture automatically? It's always that. That's what the chart is built to tell us. Damn chart. Now you already forgot it, Jeff. There it is, buddy. Damn chart. What do I have to do as the human that realizes that's not the answer?
-1.
Yeah, 1 minus that. I need the other side. So if I know the probability of one chunk, I do 1 minus that to get the other chunk. Every time I say that, I think about Goonies. What is 1 minus 0.1660? 8340? Oh, yeah. Sounds right. All right. I like it. So, here's kind of like the next level of this. That catches it up to where we left off last time. So here's kind of like the next level of this. You guys, take a minute. Can you find, let me see. Can I find something? There, let's do this. Can you find 0.1003 in here? 0.1003.
Negative?
It's got to be positive. It's all areas. I want you to really understand what I'm saying. 0.1003 in the body. In the body. You can't do that with the z-score because it only goes to 2 places. So I'm going to look in here. Can you find 0.1? Let's see, 0.1. Oh, there's the ones. 003. There it is. You guys see it? What z-score does that relate to? Careful. Negative 1.28. Do you guys see that? So if I know a z-score, I can look it up and find the area. If I know the area, I can look it up in here and find a z-score by looking back out. So what the hell did we just do? I don't know. Oh yeah, I do. If I would ask you, what's the 10th percentile? 10th percentile z-score. Oh shit. What does 10th percentile mean? That means 10% of the data should be where? What's percentile mean again? If you're in the 10th percentile on a test, are you happy? No, because you only scored higher than 10% of all the students, right? 90% scored better than you. You guys understand? You guys remember it's better because we've already done that shit, right? So if I wanted to draw this, where would I put 0.10? It's got to have 10% below it. So don't put 0.1 down here. I'm looking for the z-score. I don't know what the z-score is. This is an area. It's got to go here. So I'm doing everything in reverse. I know the probability, the area to start with. I got to look up to see what the z-score is. So this chart, just like all of mathematics, goes both ways, right? You can be jealous or whatever. So if in algebra, if I know what x is, I can figure out what y is. If I know what y is, I can figure out what x is. I can go both ways. It doesn't matter. So if I know what the area is, the closest we could get to 0.10 is 0.1003, and we figured out that's a negative 1.28. So if test scores were normally distributed and you got a z-score of negative 1.28 for your grade, you're in the 10th percentile. Your height is negative 1.28 z-score compared to everybody else's height, you're in the 10th percentile height. You are taller than 10% of other people. Right? I like it. Okay. And then the last idea before I unleash you on the not surprising to find out that I have a handout. This is all nice and good if I have z-score stuff. What if I give you this? We have a normal distribution where the mean is, what do you want, Jeff? 110. And the standard deviation is 12.9. Sure. I like it. Can you draw that picture already for me? Be careful now. What's going to go in the middle now? 110. What always goes in the middle? The mean. If I have z-scores, 0 is the mean, because that's what the mean would become, whatever it was before. I don't have z-scores now, do I? I have test scores, or whatever this is. I don't know, that's a lot of bonus. Let's say this is bowling scores. There we go. People that are on my level of bowling. 110 is a good night for me. All right, sorry. Well, I didn't need to know that about you. Oh, well, you do now. So everybody with me? Right? It was 0 before because they were z-scores. So whatever the mean was, it would have become 0. So if I change this into a z-score, what would it become? 0. Okay, good. Everybody's listening. So I'm going to put underneath that 0, just because that's the z-score it would be. So now if I ask you, what's the probability that somebody bowls more than 130? Can you put that on the picture? It's not that big of a deal. Just make sure the thing goes in the right place. The picture is supposed to help you. So, of course, 130 is going to be above 110. And where do I shade? To the right? Above, right? Greater than. I love it. So I already know from the picture my answer is going to be less than 50%. If I get an answer of 80-something%, I am wrong and I should know it. So, can I use the chart yet? Do I have a normal curve? Do I have a normal curve? Yes. But I don't have, of course, z-score yet. So how do I change this into a z-score? Kick ass. That dude's coming back into play now in a big way. So let's see what we get. So it'll be our data point that we're curious about, 130, minus the mean, which is 110, divided by the spread, which is 12.9. I'm actually trying to do it in my head. I got to stop doing it. 2.25? I don't know what it is. What is it? 4? No, 1.55? Okay, so 155. Well, I'm going to stop at 1.55 because that only goes 2 places. 11. Kick ass. Sorry. You got to remember, I'm approaching 50. So my hearing it's really weird to say that. Just wait. If you make it long enough, you'll be saying that too. 1.55. Let me put that on the picture. I want you to, is everybody, the problems we were doing a minute ago started with z-score. So I could just look them up and see if I got the answer and do 1 minus if I had to or whatever. This one starts with x scores, what we call raw scores. Yeah, it's not plural yet. Well, as that would be a raw score because I haven't processed it yet. Once I process it, now it's just like the problems you were just doing. Look up 1.55, get the area. That's not going to be the answer yet. Do you guys see that? So what do you get when you look up 1.55? Yes. Okay. 1.55. So I get 0.9394. I like it. So that would immediately go right there. Let me make a really big point out of this. Do you see how my z-scores are down here? And my areas are up here. Be nice to yourself. Z-scores can look like areas and vice versa. That sucks so bad. But just be nice to yourself. Put them in the right place. So what's the answer going to be? Yeah. Almost an evil answer. Okay. All right. So let's see. Let's see if you guys do this. All right, guys, so this is not a quiz or anything, so you guys can work together. You can have your notes out, whatever. First part's all z-scores already. The second part is not z-scores yet.